is called the multi-agent. For example, chess playing two agents. Okay. So single agent and multi-agent means when only one person or when only one agent is working in the environment, then that is a single agent. When multiple agents are working to perform the task, crossword puzzle by one. You don't play the crossword puzzle with the party or with the regular person. Right? So crossword puzzle can be solved by a single agent. Then two agents. So when we play any game or when we have any type of activity in which more than one agent is required, that is the multi-agent, right? So we have the two types of agent, that is the single agent and the multi-agent. Okay? Based on the number of people or based on the number of agents are working in the environment, it may be the single agent or the multi-agent. The next, deterministic with stochastic. Deterministic versus stochastic. Now what do you mean by that? So if the next state of the environment completely determined by the current state, you understand? If the next state of the environment completely determined by the current state, otherwise and the environment is determined except for the actions for the other agent, then the environment is strategic. Okay. So what do you mean by the deterministic, stochastic, and strategic? Just look at the example. The first example is the crossword puzzle. Now, when we play the crossword puzzle, we have some static data. Okay. When we play the crossword puzzle, we have some static data. So, for example, you take any type of crossword puzzle. You take any type of crossword puzzle. So, like this. So, this is one crossword puzzle, right? So, the when somebody crossword puzzle, or you can determine what is going to happen in the environment. What is going to happen in the environment. Like that. So we can easily determine what can be the next step. We can easily determine what can be the next step. That is the deterministic. Taxi driver, stochastic. If the agent is not able to determine the current based on the current state, the future state. If the agent is not able to determine the future step based on the current action or based on the current state, then that is the stochastic. For example, taxi driver. So taxi driver may or may not be able to understand what will happen next in future, or where is the turn, or where is the traffic, where is the signals are red and where is the signals are green. We cannot identify that. And then next one is strategy. Strategy means the logic involved in the strategy and involved logic is required to play the action, to perform the action. Then that is the strategy, right? So, for example, chess with a clock. So, this is an example of strategy. So, if the environment is deterministic except for the action for the other agent. So, when we play the chess with somebody, we know the steps. Okay, when we play the chess with someone, we know what we can perform if the agent or the another player is performing this type of task. Okay, we know this environment, right? So that is our strategy. Our strategy is decided or our strategy work based on the other activity. Okay, so this is the environment. It can be deterministic or it can be stochastic. Okay, next, episodic versus sequential. Okay, episodic versus sequential. Now, let me give an example of the Final Destination movie. So, how many parts are present for Final Destination? How many parts are there for the Final Destination? Anybody knows? Seen the Final Destination movie? Who is a fan of Final Destination? I am the fan of that movie. So, when we saw the Final Destination movie, the theme is same for all the movies, right? Same for all the movies, but are different. The parts are different. The representation is different, right? The part one may be having some another scenario. In part one, the plane is crashing, or the road accident. In part two, the plane is crashing. In part three, something. Every episode are different. Every parts are different. So that is an example of episodic versus sequential. That is an example of episodic versus sequential. environment, the agent's experience is divided into the atomic episodes. Okay, in episodic environment, the agent's experience is divided into atomic episodes. So different episodes or different parts will create the different scenarios. Okay. Each episode consists of the agent perceiving and then performing a single action. So when you observe all the movies of the Final Destination, okay, just an example. When we look at the Final Destination movies, we take all the movies. Now, start and end of the movie is near about same. That some type of accident is going to happen. Then some people are going to save. Right, some accident, and then some people will save. And then those who are saved, they are going to kill one by the nature or by the accident. Or people will die or somebody will survive. So this scenario is same for all the episodes. Or this scenario is same for all the movies, right? But the representation is different, and the quality of the agent action does not depend on other episodes. So we can't say the first part is better than for second part. So that is best in that movie. Okay. Every episode is independent of each other. So all the episodes or all the movies or all the parts of the Final Destination movie are different from each other. Another example, Transformers, Avengers. Avenger name is same, but the movies are different, right? So that is basically the episodic. That is basically the episodic agent. Okay. Or sorry, that is basically the episodic environment. Now, episodic environment is simpler. When you consider this environment, they are actually simpler. The agent does not need to think ahead. Because the thinking of the movie or thinking of thinking of the episode is to that episode only. Okay, thinking of the movie or the thinking of the episode is to that episode only. The next episode may be different one. Okay, the next episode may be different one, right? So this is the episodic environment where the agent's experience is divided into the different atomic episodes. Then sequential. Sequential means step by step or in the order. So current action or decision may affect all future decisions. Current action or decision may affect all future decisions. So when the environment is not episodic, it is a sequential. Then current action will depend on the all future decisions. So for example, taxi driver in chase. We cannot revert the action, right? It's a sequential action. We cannot revert the action which is performed at the current state. So taxi driving. So if a taxi driver made some accident, we cannot revert that back. If chase, you played some game in the chase, you played some step in the chase, we cannot revert back, right? So this is the sequential environment. Then another type of environment properties are the static versus dynamic. Now the name is itself indication what it means, static versus dynamic. If the environment is unchanged while an agent is deliberating, then it is static. So if an environment is not going to change, then it will be a static environment. A dynamic environment is always changing over time. Okay, and exactly opposite, the dynamic environment will always change over time. Right? The environment is semi-dynamic if the environment itself is not changed over time, but the agent's performance or does. So there can be two types of environment, static and dynamic. In static environment, nothing is going to change, everything will be static. In dynamic environment, everything is going to change. But we have one more type of environment, that is static or semi-dynamic. In semi-dynamic, based on the action performed by the agent, the future score will be decided. Okay, that is based on the current action, the future dynamism is decided or the future operation will be performed. Okay. So for example, the dynamic, the number of people in the street. So we cannot identify how many people can be present on the street at any moment. So that is the dynamic property or the dynamic environment. And this is a very difficult for the automated taxi driver. Then static, crossword puzzle. So you take any crossword puzzle, it will be static for that game. Okay, the crossword puzzle is not going to change for that game, it will be static. Semi-dynamic, chase with a clock. So based on the action of the another person, your action will be decided or your action will be taken. Right? So semi-dynamic, chase with a clock. So this is environment called as the static versus dynamic. Okay. The next important environment is the discrete versus continuous. The discrete versus continuous. Now what do you mean by the discrete versus continuous? If there are a limited number of distinct states. Percepts an action. The environment is discrete. Otherwise, it is a continuous. Continuous environment means you play the game like Subway Surfer, okay, or Temple Run. Okay, you play the game like Subway Surfer or Temple Run. Those environments are the continuous environment. They are not going to change. Okay, the environment is going to be continuous throughout the time. Okay, but discrete. So when we play the chess game or crossword puzzle, we know the distinct number of states. Okay, the states are fixed. Okay, no, sorry, the states are not fixed, but we know the steps, right? We know how many steps we can perform, or we know how many steps in future we can perform. So that is the discrete versus continuous. Okay, so examples are discrete, the chess game, crossword puzzle, and the continuous means automated taxi or the refinery controller. So these are the example of continuous. Next example or the next environment is known versus unknown. Known means the agent is knowing the environment. Unknown means the agent is not knowing the environment. Okay. For example, known and unknown. This distinction refers not to the environment itself, but to the agent's state of knowledge about the environment. So this is जो difference है known and unknown का. This difference is actually not related to the environment, but this property is actually related to the state of knowledge of the environment, state of knowledge of the agent. What agent knows and what agent doesn't know. Okay, what the agent is knowing, what the agent is not knowing. That is the known and unknown. So in known environment, the outcome for all actions are given. Okay, in known environment, the outcomes for all actions are given. So in known environment, the agent can know all the possible steps. Okay, in known environment, the agent may know all the possible steps. So for example, the solitaire card games. Okay, the solitaire card games. So in these games, the environment is known. The things are going to be fixed. Then agent knows what to perform, or agent is aware of the environment when he plays. But if the environment is unknown, the agent will have to learn how it works in order to make good decisions. So for example, a new video game. So when you download and install the new video game for the first time, you may or may not be aware of how to play the game. Right? So for example, the structure of an agent. Let's look at the structure of an agent. So what is the structure of an agent is? जो agent होते हैं उनका actually structure क्या होता है? Okay. So before that, what do you mean by the structure of an agent? The job of AI is to design the agent program that implements the agent function, mapping percepts to action. So in the last lecture, if you remember, I given you the two terms. I explained you the two terms. That is agent program and agent function. Okay, agent program and agent function. So the job of AI, artificial intelligence agent, is to design the agent program that implements the agent will have some set of sensors and actuators, right? Every agent will have some set of sensors and actuators. So that sensors and actuators is actually called as the word architecture. That sensors, actuators, or the structure of an agent is actually called as an architecture. So agent is basically the combination of architecture and the program. Okay. Agent is basically the combination of the architecture and the program. So architecture will contain the list of sensors and actuators that are held to work in the environment, and program is the actual implementation of the agent. So simply we can say agent is equal to architecture plus program. Agent is equal to architecture plus program. So this is the structure of an agent. So agent function is rational, and its aim is to find a way to implement the rational agent function concisely. Okay. So every agent will have some type of function. Every agent will have some type of function. So we can say that agent function is rational. Okay. And we need to find the best way to perform the